Hi, I'm Changyeo Lee, and today is the final YouTube video of the fabrication of semiconductor, and I want to tell about the deposition part and the metallization part. First, deposition part is the film deposition. Is the we stack the film on the surface, silicon surface. Uh, when we tell about the thin film, it's the under of the 100 nanometers. We tell the it is the thin film. How the film grows is the um, separate the three part is first it's a 2D layer by layer growth. Second is the 3D outline growth. Third is the 2D plus 3D mixed growth. 2D layer by layer growth is the good quality crystalline structure when we deposit about the good quality crystalline structure. Um, uh, mm, on the substrate, deposit layer by layer. It is essential to uh, uniformly atom atoms are deposited uniformly. So bonding about the atom and atoms are preferable. So it is happened about the same material, or it is stable about on the surface and other material. It must be stable. So we must when we deposit 2D layer by layer, we must deposit slowly, and three island growth is the mostly poly structure. So seed and seed are grow each other, and when the disease are meeting, and it is make the green boundary. So the mixed growth is the first 2D layer by layer happened, and when the stresses exist at the some thickness, then change the 3D island ID 3D island growth is happen, and uh, and the and the we must think about when we deposit the film is the stack coverage. So stack coverage. So stack coverage means the how cover the steps by film. So it is important. It is important to take a good stack coverage, but when the sometimes it must need poor stack coverage, like uh, when the isolate when it is essential to make the good isolation. The epsilon or relative epsilon must be small, so we use the air gap or air gap, because the relative epsilon is like one at the air. So and the CBD and PBD is the method of the deposition. Is first it's a CBD, chemical vapor deposition. uh, uh, the first the source gases transport to the surface, and by plasma or heat, and the chemical reaction exists, and last remove the gaseous product like byproducts. So byproduct must volatile because when the byproduct do not go remove away, our CBD process process essentially slower. So three process control the overall fabrication speed, and and uh, and the measure of the CBD is APCBD, plasma enhanced CBD, or low pressure CBD. Uh, LPCBD is the most good stack coverage because of the like vacuum condition. So slower process is the trade-off, and PECBD is have the advantage about the lower thermal budget because we use the plasma. So APCBD is simple, fast, but good throughput, but it is easily to contaminated. So do not use generally. So at the situation about the variability, PCBD is poor than the LPCBD. The CBD chamber is the cold chamber and cold water chamber or hot water chamber. Cold water chamber, it has a advantage about the do not happen the chemical reaction at the chamber surface, but it has the disadvantage about the control about the main wafer at the main wafer to chamber surface, and and because and hardware is the disadvantage about the periodic clean is essential, and the atomic layer deposition is very important process because the very important process because it has the cyclic fabrication. So it can we can use we can make thin film by using atomic layer deposition. So it is the we can use the LED to make the replacement metal gate and the PVD. PVD is the in the PVD process, the vacuum chamber is must be prepared, and PVD separate to evaporating or sputtering, or the first layer deposition, or molecule beam epitaxy. The PLD and MBE do not use because it is very expensive, or it requires very high vacuum conditions. So sputtering is the advantage than evaporator, because of evaporate is one direction PVD process, but sputtering can many direction to make the to deposit the film. So when the multi-target when we prepare multi-target to sputter or MB, like the component of the component ratio can we can change the component ratio. And finally, the metallization. metallization is the uh, mm, transistor by transistor or transistor or diode connection. We use the metallization, and uh, the the uh, front of the lithography to this process is the front end of line, but metallization usually uh, uh, means the back end of line. So mm, uh, conventional classical fabrication, we use the non-planar metallization, but uh, it is it is do not advantage about the fabrication. So we use the we use the planarization. Metallization is needed. So when we because about the device size is scaling down. So when the conventional metallization has the uh, non-planarization is the uh, disadvantage, because when the pottery saw process needed, the PR is, photoresist is uh, not planar. So it is the problem about the depth of focus, and uh, so we must chemical mechanical polishing uh, before the metallization. And we when um, in the past we used aluminum contact, but it is a problem of the aluminum spiking or electron migration. So in the modern contact or plugs, we use the tungsten. Uh, in today's semiconductors devices, we must reduce the contact resist. So um, we must reduce the contact resistance to enhance the device performance. So we go to the ohmic contact and Schottky junction or Schottky diode. So in the interface about metal to semiconductor interface, the high doping is needed, because when we doped at the interface highly doping, it can electrons or hole at the metal tunneling to the semiconductors. So we release the dipole and enhance the uh, ohmic contact and the Schottky junctions. And MIS contact is needed to, because the variable pinning. So when we put the insulator by oxidation and make the insulator, it can tunneling electrons and holes can tunneling via to semiconductor or metal. So and today's semiconductor fabrication, we use the silicide last fabrication to maintain the silicidation, because we want to reduce the contact resistance. And the electroplating, the copper do not cannot dry etching, so we use the damascene process to electroplating copper and metallization. And direct contact has the overlay problem. So reduce to reduce the overlay problem, we use the self-aligned connect like SEC. To use when we use the self-aligned contact, the device performance can a little bit degrade because of the parasitic capacitance, but at the back end, of the line, to remove the parasitic capacitance, we use the low K material.